Hi, and welcome to the videos for section 1.4 for Math 126. There's 3 videos for this section, and this is the first of the 3 videos. In section 1.4, we're going to be looking at rational expressions. So just as in the first chapter, first section, when we were talking about rational numbers, rational meant what? It was a ratio. It was a fraction. An expression, like we just saw in the last video for section 1.3, an expression is just a combination of letters and variables with plus and minus signs, or multiplication, division. So a rational expression, definition for you here, is a fractional expression where both the numerator and denominator are polynomials. So what I like to tell people, the way I like to think of these are basically just fancy fractions. So you have some examples, so i.e. it's a fraction, I have some polynomial in the numerator, let's say 2x, and I have a different polynomial in the denominator, maybe x minus 1. Or maybe you have just x in the numerator and then you have x squared plus 1 in the denominator. You could just keep creating these all day if you wanted. A fraction with one polynomial in the numerator, one polynomial in the denominator. When we're dealing with these rational expressions, we have to be ultra concerned with the domain of an expression, of an algebraic expression. So what is domain? What does that mean? When we're talking about the domain of an algebraic expression, the domain is all the values that we could put into the expression without causing big problems. What do I mean by big problems? Well, let's look at this guy. I couldn't have x is equal to 1, right? Because if x is 1, I get 1 minus 1 in the denominator, 0 in the denominator, which makes it undefined. Bad news. We don't want zeros in the denominator. So I couldn't pick x is equal to 1. Anything else would be okay. But in that case, I can't have x equals 1. What if one of my algebraic expressions has a square root in it? Well, what do I know about any even root? Square root, fourth root, sixth root, etc. I can't have a negative number underneath a radical symbol. So when we're talking about domain, that's what we're talking about, is what values could we plug in without causing any math issues, so to speak. And this is important. You're going to use this all the rest of the semester here. You're going to use this in 127. If you have to go into 181, you're going to use it a lot. Probably every day you're going to be talking about domains of functions. And so it's important to understand this concept. So domain of an algebraic expression, as I sort of mentioned, we'll put it in words here, is all the values that a variable is permitted to have. So let's look at a couple examples. So the first example, we want to find the domain The first one is 2x squared plus 3x minus 1. So what values can I put in here? What values can this variable, is it permitted to have? Well, as I mentioned, for our purpose here, for this class specifically, we're worried about two things. We're worried about denominators, and we're worried about radicals. So does this polynomial have a denominator? No. So I could pick any number I want, and it's not going to give me 0 in a denominator because no denominator exists. What about radical? Well, there's no radical in this polynomial. So that's not an issue for me. So essentially then, what is my domain for this polynomial? The answer is what? All real numbers. I can pick any number I want, plug it in here, and it's not going to cause me any issue. How about example number 2? So this rational expression, I have x in the numerator and x squared minus 5x plus 6 in the denominator. So do I have any radical? No. So that's not a concern for me. Do I have a denominator? Yes, I do. So I have to be super careful here. Why? Because my denominator here cannot be 0. So I need to find out what values, if I pick for x, is going to make this guy 0. So how do I do that? I set this equal to 0. Or if I want to say this cannot be equal to 0. If I factor this, and this is why we did the whole last chapter, or last section, this is what? This is minus 2 minus 3. So x minus 2 times x minus 3 can't be 0. So we're using what? The 0 property rule. So if these can't be 0, I want to find out what values will make this 0. So what value x minus 2 is 0? X minus 3 is 0. Again, this is by 0 property rule. And 0 property rule just says what? If I have a times b is equal to 0, then either a is 0 or b is 0 or both are. And we assume that they both are in this case. So that means what? X equals 2 and x equals 3. So x can't be equal to 2. And x can't be equal to 3. Any other number is fine. It's not going to cause me a problem, but I can't have these numbers. So if we want to put it in like our set notation, we say that the domain is any value of x such that x is not equal to 2 or x is not equal to 3. Now, I'm not going to get super picky in terms of your notation if this is on an exam. If you just get done here and you do this, boom, x can't be 2, x can't be 3. I'm going to assume that you know what you're talking about and you know how you're finding the domain here. If you don't put it in set notation, I'm not going to get bent out of shape over it. I want to know, do you know this can't be 0, and you tell me what those values are, more so than I'm concerned, can you write it in mathematical set notation form? And then lastly, number 3. What if I have the square root of x over x minus 5? So do I have a denominator? Yes. Do I have a radical? Yes. So I have to be careful with both of these. So let's do the denominator first. That looks like it might be the easiest for us. X minus 5, this cannot be 0. So that means what? X cannot be equal to 5. Any other value is fine in terms of the denominator. I can pick any other value that I want. It won't make it 0, but I can't have x is equal to 5. Now what about the numerator? How do we handle this? This is a square root. So when we have an even root, that means what? It means the value underneath, so the radicand has to be what? Greater than or equal to 0. So I can't have, even though in terms of the denominator I could have any number I want, so I could say that x is equal to -10, that's fine for the denominator, but it's not fine for the numerator. Why? Because square root of -10 is not a real number, so that would be a problem. So I have to essentially then combine these two guys, saying that my domain for this rational expression is x is a positive number, but x can't be equal to 5. And there's a few ways we can go about writing this. Again, you could do it set notation. If you get to this point and you circle that, that's fine. We'll learn some set builder notation later with unions and things of that sort. But for now, if you're given this and you say, what's the domain, and this is what you tell me, that's going to be good for me. So, as I said, big thing with finding domains at this point, and actually even going forward, 127, 120, and 181, is there a denominator? Is there a root? Those are the two ones to always start with. And as long as you're not going to put a 0 in the denominator, or you're not going to put a negative number under a radical sign if it's an even root, then you're okay. Last thing from video 1 is simplifying rational expressions. So I'm just going to abbreviate it RE so we don't have to keep writing rational expressions. So recall, if we had a fraction, a times c over b times c, well, what could we do? We could cancel out the c's, and this is equal to a over b. The same still holds true for rational expressions. If I can convert the numerator and denominator into a product of binomials or maybe a greatest common factor, if I can pull it out, I can cancel out any common terms. So for example, if I want to simplify x squared minus 1 over x squared plus x minus 2. So one thing I didn't deal with, and I probably should have, in the factoring video for 1.3, I told you guys when you have 4 terms, that's your red flag for what? 4 terms, factor by grouping. That should always be your first thought. When you have 2 terms, especially if it's an x squared, your first thought should be difference of squares. So can I write x squared minus 1 as the product of 2 binomials, but difference of squares means just simply they're going to look the same, although one's a plus, one's a minus. Difference, because of the minus sign here, so difference of squares when you have 2 terms. If it's 2 terms and there's a minus sign, that should be your first thought. What's the square root of 1? It's 1, so plus 1 minus 1. This is what's known as a difference of squares. When we FOIL it, the middle terms will cancel each other out, and we're just left with the first and the last pieces. How about here? Well, if I'm going to simplify this thing, I need to have a common term, so I should end up with either an x plus 1 or an x minus 1. So what do we have here? An x and an x, negative 2, and then we want to end up with a positive 1, so that's going to be what? Plus 2 and minus 1. So because this is a product here, I can cancel out the x minus 1's, and this leaves me with what? X plus 1 over x plus 2. Now, so that's it. That is our final answer. But what people always they always have the urge to do is start canceling out plus and minus pieces. When you have a plus or minus sign in the numerator or denominator, you cannot cancel out the pieces. I can't say, oh, this x will cancel with that x, so it's just equal to 1/2. That's not true. You cannot do that. And so where I'll see this a lot is like, well, it's just that. So you might have like, whatever, x over x plus 3. They say, oh, this x cancels with that, so it's 1/3. No, that's not the way that works. If there is a plus or there is a minus attached to the variables and the numbers, you cannot cancel. It's either everything or nothing. Like right here, I'm canceling out an x minus 1 with an x minus 1. I'm not canceling out just a little bit and piece here and there. It's everything, all x minus 1, all x minus 1, or nothing. So your answer here should be x plus 1 over x plus 2. So sorry if I was on a soapbox there. It's just I see that happen all the time. People will get to here and have the right answer, and then they say to themselves, oh, I think I need to cancel out the x's yet so that I end up with 1/2. And that's not, it's not allowed. You can't do it. It doesn't work that way. So that's it. That's the end of video 1, your introduction to rational expressions, the domain of expressions, make sure you know that, and then simplifying once we finally get to the end. So come on back and we'll look at video 2.